Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends, welcome back to the sessions of computer networks. The last session and before last sessions we have completed chapter 1 consists of fundamentals and open system interconnection and a layered structure. So we got the second topic, that is the physical layer and the data link layer. We will discuss for some time concept, then afterwards, as usually, we do classroom workbooks. So first sometime I will discuss the physical layer, then after that we will see the concepts of data link layer. Okay friends? Now what is the concept of the physical layer? First let me discuss about physical layer. As we know, some of the responsibilities of physical layers, like it deals with physical characteristics of the medium. What is the physical characteristics of the medium? It try to see the concept of a signal, and are there any delays are there or not in the signal. If there are any delays are there, then throughput is equal to increased or decreased. So those are the main signaling characteristics we will also highlight in physical layer, apart from its regular responsibilities. What are the physical layer responsibilities? I told you physical layer responsibilities are number 1, actual transmission, and number 2, topology identification, and number 3, communication mode, number 4, transmission mode, number 5, transmission technology, number 6, media, number 7, type of switching, etc. Apart from that, it also deals with physical characteristics of the media. Okay, and now these are already been discussed. Physical layer is involved in actual transmission, and we also learned topology. We also learned communication mode, whether it is off duplex or full duplex or simplex, and transmission mode we have seen parallel or serial, and transmission technology we have seen either 1 to M or 1 to 1, and media wired or wireless, and we also seen type of switching like circuit or packet or message. We also see deals with physical characteristics of the medium. Apart from this, there are some delays. Delays occurred during data transmission. Those are the things we will highlight in this lecture. So if you observe carefully, as far as physical layer concerned, the first delay is transmission time or transmission delay. What is the point? The meaning of transmission time or transmission delay is nothing but, so look at the diagram now. This is the medium, here is the sender, here is the receiver. So now if you observe where the transmission time comes, transmission time comes in such a way, time takes by sender to push the data bits onto media. That time is known as transmission time. Okay, transmission time at the rate packet. Okay friends, so this is a transmission time. What is a transmission time? What the definition is telling you? Definition is telling in such a way, time takes by sender to push data bits of packet or a frame into physical medium. Okay, this transmission time for data is vary based on message size and sender's bandwidth. Okay, what is the meaning? We will see in the next slide. Just copy this. Yeah. Well, friends, now we will see one small numerical on that example based on transmission time to send the data packet or to send the data frame. Have a look at this. For example, bandwidth is equal to 1 Mbps and message or packet or a frame size equal to 100 bytes. He is asking what is the transmission time. I want to highlight few important points in order to solve the problems using delays. What are the important points is just understand carefully. 1 byte equal to 8 bits. 1024 bits equal to 1 kilobit. And 1 KB equal to 1024 kilobit equal to 1 MB. 1024 MB equal to 1 GB. Okay, friends. Now this I can write in such a way. 1 KB is nothing but 10 power 3. 1 MB is nothing but 10 power 6. 1 GB is nothing but 10 power 9. This I can write 2 power 10, 2 power 20, 2 power 30. Okay. If at all you ask bytes, you convert them into bytes. If at all you ask bits, convert them into bits. And one more important point is timing. What is that? 1 ms is equal to 10 power minus 3s. 1 mus is equal to 10 power minus 6s. 1 ns is equal to 10 power minus 9s. For 1s, there are 10 power 3 ms. For 1s, there are 10 power 6 mus. For 1s, there are 10 power 9 ns. So these are the important points I want while solving the problem. So the solution is, as we know, he has given a message size. He is asking what is the transmission time. Transmission time for sending data to media is known as TT for data. So TT for data is nothing but the length of the message you are sending using the bandwidth is the concept of TT. So what is the message size is given? 100 bytes are given. And what is the bandwidth is given? 1 Mbps is given. Denominator is in bits and numerator is on bytes. Therefore, convert. So your 100 into 8 divided by 1 MB, how much I can write? 1 MB is nothing but 10 power 6 I can write. Okay, then it becomes 800 into 10 power minus 6s. What is the meaning? 10 power minus 6s means how much? 10 power minus 6s is nothing but 1 mus. Therefore, your answer is finally 800 microseconds. This is what is a transmission time based on the bandwidth and based on the frame size. Okay? Copy this. Yeah. Well, friends, now let us see one more example based on this. This time, I said one point. What is the one point? The transmission time may be vary based on bandwidth and based on the packet size or frame size or message size. Now, I will just earlier problem with 800 microseconds. Now, what I do, I will just change them. This time, I am saying message size is only 10 bytes. With the same bandwidth, this time frame size is very less. Therefore, it takes very less time to push your data onto the media because your transmission time depends upon the size of the data you are sending using the bandwidth you are using. So we can do in a quick manner. So TT for data is nothing but L by B. L stands for message size and B stands for sender bandwidth. L is equal to how much, friends? 10 bytes, and bandwidth is equal to 1 Mbps. So 10 into 8 because the numerator is in bytes and 1 MB is nothing but already it is mentioned 10 power 6 BPS. This is in bits because already it is trying to convert. So 80 into 10 power minus 6s, that is nothing but 80 meos. That's why I told you this transmission time for sending data can be increased or decreased. That all depends upon your frame size and bandwidth. Okay, friends. Now we will see the second delay, that is propagation delay for data. This is also known as propagation time for data. Okay, what is this? TP for data. What is TP for data? Time takes by bit or a signal or a packet to make a physical journey from one end of the medium to other end of the medium. This is the point. So now we will be learning a new delay which is different from previous one. What is the diagram? The diagram is, this is the medium, here is the sender, here is the receiver, this is the starting, this is the end of media, start of media. Okay. Now, once please recollect the previous knowledge. What is the previous knowledge? What is the first delay? Time takes by a sender to push the data into media is a what? TT for data. Once you send the data to media, then what will happen? It takes that data and make a physical journey from one end of the media to other end of the media. This is known as what? TP. So therefore, this propagation TP for data depends upon how much distance the signal is transmitted by using speed of the medium. So this is the rule for what? Propagation time. How much distance the signal is traversed from one end of the media to other end of the media with the speed of the medium. As far as this, if I am saying, for example, distance is equal to 10 kilometers and speed is equal to 2 into 10 power 8 meters per second. He is asking what is TP for data propagation. As we know, the solution is nothing but TP is equal to distance by speed. How much distance the signal has to traverse? 10 kilometers. The speed is 2 into 10 power 8 meters per second. Numerator is in kilometer, denominator is in meters, so therefore convert the numerator. Therefore, TP is equal to 10 into 10 power 3 meters by 2 into 10 power 8 meters per second. So 2 5s. So TP is equal to 5 into 10 power 3 into 10 power minus 8s. Therefore, TP is equal to 5 into 10 power minus 5s. This is your answer. Okay, friends. And now here I want to add a point. What is that? TP can be vary TP can be vary based on what is that? Distance and speed of the medium. So we will see another example by taking high distance or low distance. So therefore TP is equal to up and down. Copy it. So now we see we will decrease the distance or increase the distance or increase the speed or reduce the speed, automatically the TP is going to be vary based on distance and speed. So let us do one more small problem, that is distance is equal to 1 km and speed is equal to 2 into 10 power 8 meters per second. So he is asking what is the TP. Since distance is reduced, TP is nothing but distance by speed, and this is 10 power 3 meters by 2 into 10 power 8 meters per second. So therefore I can say 5 into 10 power 2 into 10 power minus 6s minus 8s, that equal to 5 into 10 power minus 6s is nothing but 5 mus. See, it is reduced. Why? Distance is less. So what do we understand here? That is, if distance is increased, then what will happen? TP will be increased. And reverse. If distance is decreased, then TP will be decreased. This is the point in this. And another example is, this time I want to calculate TT for data as well as TP for data. Both I want to calculate. So this requires L value 100 bytes and bandwidth is equal to 1 Mbps. This requires distance is equal to 1 km, speed is equal to 2 into 10 power 8 meters per second. So therefore, what is the TT for data? TT for data equal to L by B equal to 100 into 8 divided by 10 power 6 bps. You know why I did into 8, because it is in bytes, this is in bits. That's why there is a need of conversion of bytes into bits. So it is altogether 800 into 10 power minus 6s. And you want to calculate TP here. TP is equal to distance by speed. Already it is been calculated, 1 kilometer by 2 into 10 power 8 meters per second. So 1 km is nothing but 10 power 3 meters by 2 into 10 power 8 meters per second, that equal to 5 US. This equal to 800 microseconds. This is how you can do both together. Now third delay, that is, once look at the diagram. Here is the medium, one end to other end. Here is the sender. Here is at receiver. This is start and this is end of the medium. Now we learn the first one, time takes by a sender to push the data to media is a what? TT for data. Once data comes to media, it will make its journey. It is nothing but TP for data. Once data reached to receiver received data and give positive acknowledgement. So, what is a positive acknowledgement? If at all the frame or a packet or a message is correctly arrived, then he will give what? A positive acknowledgement. So, now I am discussing about the third delay is a what? Transmission time for acknowledgement. It is nothing but acknowledgement size divided by who gives acknowledgement? Receiver. So receiver's bandwidth required. For example, acknowledgement size equal to 10 bytes and receiver bandwidth is equal to 1 kbps. He is asking what is the TT for acknowledgement? The answer is so TT for acknowledgement equal to 10 bytes by 1 kbps. How much it is? Numerator is in bytes, denominator is in bits. So 10 into 8 divided by 10 power 3 bits per second. This is nothing but 80 into 10 power minus 3s. So what is the third delay? Third delay is transmission time for acknowledgement. What is the meaning? Time takes by acknowledgement packet to reach to media. This is a transmission time for acknowledgement. Okay friends, just copy this. Yeah. Well, friends, I hope so you understood how to calculate propagation time, how to calculate transmission time for acknowledgement, how to calculate transmission time for acknowledgement, and how to calculate time for transmission time for data. So far I taught you three delays. One is sending data from sender to the media, that is the TT for data, and the other one, propagation of data in the media from one end of the media to other end of the media, and third one, once the data is received by the receiver is going to give you positive or negative acknowledgements. So we need to identify the time taken by receiver to push the acknowledgement packets into media. So what is the third delay? The third delay is TT for acknowledgement. What is the meaning? Time takes by receiver to push acknowledgement bits onto media. Okay. And there is an important point. This can be negligible by default because transmission time for acknowledgement is very small. That's why you can ignore this. Okay? And the fourth delay is TP for acknowledgement. What is the TP for acknowledgement? Time takes by acknowledgement signal or acknowledgement bit to make physical journey from receiver end to sender end. Okay. You know this. It depends on distance and speed of media. Okay. What is TP for acknowledgement? Distance by speed. Okay. Now I will give small example here. That example is sender and receiver uses same channel. Distance is equal to 10 kilometers. Speed is equal to 2 into 10 power 8 meters per second. Now he is asking you to find a TP for data and TP for acknowledgement. How to find? The solution is TP is equal to distance by speed. Here also TP is equal to distance by speed. So I can calculate one. So therefore it is applicable for both because both uses what? Same channel. So 10 kilometers by 2 into 10 power 8 meters per second, and this equal to 10 into 10 power 3 by 2 into 10 power 8. Finally, the answer is 5 into 10 power minus 5s. So, what do we understand? TP for data 5 into 10 power minus s, TP for acknowledgement 5 into 10 power minus s. Therefore, TP equal to 5 into 10 power minus 5s for both, because both uses what? Same channel. Okay friends, so what do we understand? TP for acknowledgement is equal to TP for data whenever both uses same channel. If both are using different channel, then you have to calculate separately, one for data, one for acknowledgement. Okay, that example we see in next slide. So copy up to this. Yeah, just have a look at friends. Now this time we will change a bit like this. Sender comma receiver uses different channels. So find TP for data, TP for acknowledgement. So sender side, distance is equal to 1 km, speed is equal to 2 into 10 power 8 meters per second. And the receiver side, distance is equal to 10 km and speed is equal to 2 into 10 power 8 meters per second. So now we want to find TP for data is how much, and we want to find TP for acknowledgement is how much. So Here in this case, earlier we are using same channel and twice. If I calculate TP for one time, then that is applicable for second time because both use the same channel. But here, since he has given both are using a different channels, so we have to calculate separately for them. So we'll meet in the next session.